Hey everybody, welcome. Today we're going to talk about our quadratics that we talked about yesterday, or you guys got to graph and see what's going on, right? So these functions are called quadratic functions. And a couple things that I just kind of want to run down with you guys that hopefully you noticed from doing that yesterday that you can kind of tell from what's going on with quadratics. So first of all, quadratics are any kind of function that has this x squared term as like the main power, right? The biggest degree is x squared. So we're always going to have some sort of x squared in these functions. That's going to be the biggest degree is the x squared. And we could have some other stuff, as you saw in your guys' examples, especially when you got to set 3. There's definitely some more stuff going on, but they all kind of are going to look the same. And they kind of have this bowl shape about them, right? Kind of like this. Some people in class said they looked a lot like the absolute value functions we talked about, which is true. Especially if you noticed in their tables, right? So if we use a parent function, just f of x equals x squared here, we can easily see negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, and then we can see that they still have that symmetry that the absolute value functions had, right? They have the same thing going on each side. This point, right? This one, like right down here. We could do this if you want to do that. This is called the vertex. And we're going to do a little bit more with the vertex of these parabolas than we did with our absolute value functions. That vertex is going to tell us a lot of information. It's really important. For one thing, it's kind of our switch spot. So, for example, from infinity to 0, this graph is decreasing. Right? So from here, if we go just from left to right, our graph's going down until we get to this point. Then, from there, from 0 to infinity, so I can even write from negative infinity to 0, from 0 to positive infinity, this is going to be increasing. And so that just basically means what's going on with the graph. So usually in parabolas, at some point, it's going to be decreasing for half of it. It's going to be increasing for the other half. That's just what's going to go on, right? Because we have that vertex spot that's going to kind of tell us, like, here's the middle. Here's what's going on one side. Here's what's going on the other side. When we're talking about increasing, decreasing, we always look at it from left to right. So we're thinking of it as the x's go, right? So as the x's go from negative infinity to infinity, the y's decrease. As the x's go from 0 to infinity, the y's increase. So as the x's go, what's happening with the y's, if you want to think of it that way. So that's kind of general. Oh, I didn't talk to you about the name. This shape is called a parabola. Quadratics are always going to give us some form of parabola, this bowl shape that does have this vertex. It does have a line of symmetry, which we'll talk about a little bit as we get farther. Right, like for example, on this one, on the y-axis here, this side is going to be symmetrical. Yikes. To the other side. And we can kind of see that in the table, right? Negative 1 and 1 are the same thing. Negative 2 and 2, they're the same thing. If we kept going forever, any number and its negative counterpart are going to be the same thing. So that's cool. What else is going on here? There was a couple different things that we talked about that kind of got changed in your guys' problems. So one of those things is, what if we have this number out in front? So if I threw out f of x equals 4x squared. This number out in front is going to change how quickly we increase or decrease. That's like the steep level, right? So for example, I'll give you a nice little visual here. If my parent function looks like this, putting a 4 out in front here means that we're going to go even more rapidly. So a number in front here that's greater than 1 should have increased your parabola's rate of change, that speed that it's increasing. All right, it's still kind of curvy, but it's going to go up real skinny like that. If we change this number to, let's say, a fraction, like some of them were, so maybe we do like 1/3 here. So if this number is less than 1, right here, we're going to get a really wide bowl. Right, something like that, where it's going to really widen it out. So that number out in front is going to tell us how wide it's going to be, or how narrow it's going to be as it goes up. The bigger the number, the skinnier it's going to be. The fraction, less than 1, we're going to have real wide as it goes out. So that number kind of is going to impact there. And then some of them even had a negative in front of them, right? And that negative, just like in every other kind of function that we've talked about, is just going to take your graph and it's going to flip it. So now, instead of it going decreasing and then increasing, now it's going to increase and then decrease. So we reflected it over the x-axis because of that negative coefficient in the a spot there. All right, very cool. So there was some other shifts that went on, right? So when you added things at the end, you saw that it was a vertical shift. We'll talk about that a little bit. And you guys even saw the inside part, right? So maybe there was something that looked like this, f of x equals 2, and then inside here it's just x minus 4 squared. So the part that's squared is not just x, there's an x minus 4. So that kind of stuff, those shifts are going to be very similar to our shifts. And we're going to get into those a little bit more when we talk about vertex form. Just kind of talk about what that looks like and what we need to know about vertex form, where our vertex is going to be. But basically those shifts, the vertical and horizontal shifts, we're going to work exactly the same way that all of our other shifts have worked so far. So that's cool. We know that. That's awesome. Increase, decrease. Yeah, cool. So that's kind of like general quadratics, parabolas, in a very quick little nutshell of what's going on here. We talked about this number out in front, that a coefficient, if you want to call it that, as we're getting used to kind of calling those things those a coefficients. Is going to determine the the width of the function. We have some vertical shifts, right? If I threw in like a +2 here, +3. We have some vertical shifts. We have some horizontal shifts. We have reflections over the x-axis with the negative. Yeah, talked about increase and decreasing. That's pretty good. So, parabolas are very, very similar to absolute value functions. They have a lot of similarities with exponentials even, just with 1/2 of them, right? The side that kind of increases looks very similar if this side just kind of leveled out and had an asymptote. Yeah, lots of stuff going on here. We are also going to talk about kind of some what that vertex is going to do to our domain and range as we go, and just be more specific about that. And yeah, that's just kind of a general intro video on parabolas. So tonight your homework is just kind of like looking at some numbers, saying what they're going to do to our functions, and then also looking at intervals, talking about if they're increasing or decreasing. So I don't care if you use set notation or interval notation for that, and just kind of talk about, if you want to say when x is less than 0, it's decreasing. When x is greater than 0, it's increasing. Or you can, use the intervals and stuff like that. But yeah, let me know if you guys have any questions about parabolas so far. We're going to obviously go into a lot of depth on a lot of different parts and pieces to this. So just kind of over the rest of this week, hopefully by the end of the week, you guys are going to be parabola experts. All right? Cool. I'll see you guys later.